Hi, welcome to this video. I'll be showing you how to solve the question shown on your screen using the fastest possible method. If the basic algebraic method is all you know, then this video is for you. Even if you know the Pascal triangle method, this video is still for you. I'll be showing you the ultimate method you need to expand any bracket irrespective of how high the exponent is. So let's solve this question using combinatorics, the ultimate method. Now, to solve this question, we will need to use the combination rule, and the combination rule states that n combination r is equal to n factorial over n minus r factorial. That means if we have 7 combination 3, this is going to be equal to 7 factorial over 7 minus 3 factorial, 3 factorial. And this simplifies to 35. All right, so let's apply this concept to expand this bracket. Now, the rule is to start counting from 0. So we're going to have 6 combination 0, 2x raised to power 6. So the first term takes the entire exponent, while the second term takes 0 as its exponent. Now take note that you have to preserve the sign. If the term is negative, you have to keep negative inside the bracket. Okay. Now the next term will be plus 6 combination 1. Now the first term is going to reduce by 1, so we'll have 5 here. And the second term is going to pick up by 1, so we have 1 here. So we're going to continue in this fashion. The first term will keep on decreasing by 1, while the second term keeps increasing by 1. Now we're going to have plus 6 combination 2. So we have 2x raised to power 4 minus 5y raised to power 2 plus 6 combination 3, 2x raised to power 3 minus 5y raised to power 3. Then we have plus 6 combination 4, 2x raised to power 2, that is minus 5y raised to power 4, plus 6 combination 5, we have 2x raised to power 1 minus 5y raised to power 5. And then finally, we have plus 6 combination 6, 2x raised to power 0 times minus 5y raised to power 6. Now, this is the entire setup we need to get our answer. So let's start simplifying right away. So here, 6 combination 0 is 1. So we have 1 times 2x raised to power 6, that's 64 x raised to power 6, minus 5 raised to power 0 is simply 1, plus the second term, 6 combination 1 is 6, so we'll have 6, 2x raised to power 5 is 32 x raised to power 5, and minus 5 raised to power minus raised to power 1 is just minus 5, plus 6 combination 2 is 15, 2x raised to power 4 is 16x raised to power 4, and minus 5y squared is 25y squared. Now the next one is 6 combination 3, that is 20, so plus 20, 2x raised to power 3 is 8x cubed, minus 5y raised to power 3 is minus 125 x cubed, then plus 6 combination 4 is 15, so 15 times 2x all squared is 4x squared, then times minus 5 raised to power 4 is going to give you 625. This is y raised to power 3. Apologies. Y. So this is going to be y raised to power 4. Then the next one is going to be 6 combination 5. So plus 6 combination 5 is 6. So you have 6 brackets. 2x raised to power 1 is 2x. And minus 5y raised to power 5 is minus 3125 y raised to power 5. And the final one, 6 combination 6 is 1. 2x raised to power 0 is 1. And minus 5y raised to power 6 is going to give you 15625 y raised to power 6. So we finish expanding. Now the final step is to multiply out the numbers and write out our solution properly. So if you multiply out the numbers, you're going to have 64 x raised to power 6. Then if you multiply out 6 times 32 times minus 5, you're going to have minus 960 x raised to power 5 y. If you multiply out 15 times 16 times 25, you're going to have plus 6000 x raised to power 4 y squared. If you multiply out 20 times 8 times minus 125, you're going to have minus 20,000 x cubed y cubed. If you multiply out 15 times 4 times 625, you're going to have plus 20,000 x squared y raised to power 4. If you multiply out 6 times 2 times minus 3125, you're going to get minus 37,500 x y raised to power 5. And finally, if you multiply 1 times 1 times 15,625, you're going to have plus 15625 y raised to power 6. So this is your expansion for this question. All right. This method is the best method to use for expanding large exponents because you're less likely to make mistakes in your expansion. Now onto the bonus question. You can use this to challenge your friends and see how much competency they have in expanding brackets with large exponents. What is the coefficient of x raised to power 10 in this expansion, 2x minus y all raised to power 15? Now that you've understood how to use combinatorics to expand brackets with large exponents, let me show you how to quickly fish out the coefficient of any term you want. So we want to find the coefficient of x raised to power 10. Now, if you remember what I told you about expansion, the exponent for x will start at the maximum and keep reducing by 1. So by that, if we start from 15, if we want to stop at 10, that means we're looking for the 6th term of this expansion. And how do you write the 6th term of this expansion? It's going to be 15 combination 5. Remember, we started from 0, from 15 combination 0, combination 1, combination 5 is the 6th term. So this will be 2x raised to power 10 and minus y raised to power 5. So this is how we're going to get the coefficient of x raised to power 10. So what's 15 combination 5? This is 3003 times 2x raised to power 10. This is 1024 x raised to power 10. Then minus y raised to power 5. It's an odd power, so you're just going to have minus y raised to power 5. So if we expand this, we're going to get minus 3075 0.072. X raised to power 10, y raised to power 5. But we're interested in the coefficient, so this is the coefficient. Was that easy? Be sure to subscribe to this channel so you can have more interesting math like this. See you in my next video.